All right, everybody. Sorry about that. I messed up on that last problem. I was rushing a little bit. The bell's about to ring, so I'm trying to get this done before school starts. So please forgive me. I'm going to go ahead and do this problem again. Again, we have an initial velocity of 27 meters per second. It slams on the brakes, and so it takes her 4.8 seconds to come to a stop. So my final velocity is 0, and it takes 4.8 seconds to do that. And how far will the car skid? Well, that means our initial position is just going to be 0, and our final position is going to be our question mark. Now, the problem here, and the problem that tripped me up here, I assumed there was an A in there, but there wasn't, and I was rushing myself, so try not to rush yourself. I did end up catching myself, though, because I realized that there was 2 unknowns in my final equation there. This is actually a problem that doesn't have a kinematic equation that you can use to solve. So what typically happens whenever we don't have a kinematic equation that matches our variables exactly, we have to use 2 of them, okay? So notice that kinematic equation number, all of them have acceleration, and I don't have the acceleration. The acceleration is not given to me in this problem. That was why I messed up in the last one. The acceleration here I need, because the acceleration isn't every kinematic equation. So if our unknown is final position, then that gives us 2 unknowns, at minimum 2 unknowns. So I actually have to use kinematic equation number 1 to find what the acceleration is. And just so I have enough space, I'm going to go ahead and do that over here. Because I do have the initial velocity, the final velocity, and the time, that does allow us to get the acceleration. So my final velocity equals the initial velocity plus the acceleration times time. Our final velocity is 0, so that can go away. Again, I have my given here. I have 2 unknowns at this point, which I realized far too late. And so I have 0 equals the initial velocity plus the acceleration times time. Now I'm going to solve this for my unknown here, which is the acceleration. I subtract v naught from both sides. So I get negative v naught equals the acceleration times time. And then I divide both sides by the time. And numerator t, denominator t, so the acceleration is negative initial velocity over time, and that is going to be negative 27 over the time, 4.8 seconds. And when I solve that, when I substitute in my values, that's going to be 7 divided by 4.8. That's going to be 5.625. Now here I'm actually going to not round to 3 digits. This is what my calculator tells me. I'm going to use as many digits as I can here because this isn't my final answer. I don't want to actually round things until I get to my final answer. So now that is actually a given. Now my acceleration is no longer a question mark. It is negative, it's negative, see the negative there, negative 5.625 meters per second squared. Now I can use kinematic equation number 3, okay? So my equation, and actually I can use kinematic equation number 2 as well. And let's go ahead and use kinematic equation number 2 because it's already solved for what we're looking for, that final position. So x equals x naught plus v naught t plus 1/2 the acceleration times the time squared. We got some zeros. Our initial position is 0. No final velocity in this equation, so we just have final position equals v naught t plus 1/2 a t squared. And then we just, it's actually already solved. So the first S is already done. And so now we can just go, oop, there goes my light. Now we can just jump to our substituting. And so I just substitute our values. Initial velocity is 27 meters per second. Our time is 4.8 seconds plus 1/2 times the acceleration, which is negative 5.625 meters per second squared, times the time, which again is 4.8 squared. All right. Now I'm going to plug all that in my calculator. So I'm going to have 27 times 4.8. So our final position is going to be 129.6. And then notice the plus, but then I have a minus here. So it's going to be minus whatever the product of these 3 numbers is going to be. So that's going to be 1/2 times 5.625 times 4.8 squared. And I get minus 64.8. And so if I just subtract that from 129.6, I get our final position of 64.8 meters. Okay. And I totally did this on purpose. I totally messed up that last one just to show you what happens when you make a mistake. That is a complete lie. But yeah, if you ever run into where you have two unknowns in an equation, you got to find another equation. And so that's what told me to use another equation to find my acceleration first. All right. Sorry about that. Notice that this is the reason we have the three different kinematic equations, because sometimes we know certain things that are not in one kinematic equation but are in another. Sometimes we're asked to solve for things that aren't even in a particular kinematic equation. So that's why filling out your given and your unknowns, making a list out of those and then just using them to choose the right equation. But pay attention, be a little more careful than I was. Anyway, I'm going to call it there because class is about to start. So I'll see you guys soon.